Very excited to be here today with Simon, the co-founder and CEO of Inferact, which is a business built by the creators and maintainers of vLLM, who are looking to kind of up-level the game of inference, which has become a lot more important in today's day and age. I think Jensen Huang said it best that he sees inference going up by 1 billion times over the next few years, and there's no one better to discuss the inference market, the inference trends, and what's going on in that world than Simon and his team, being, again, the builders and creators of vLLM. So, Simon, why don't you quickly introduce yourself, tell us a bit of what you're up to, and then maybe also respond to kind of Jensen's comment. Like, what do you think about the inference going up by 1 billion times? Is that hyperbole? Is it real? Would love just your reaction to that.
Hey, Jamin, thank you for having me. Hi, I'm Simon. I'm the CEO and co-founder of Inferact, a new company built around to accelerate the adoption of vLLM. So my background has been actually in inference over the last almost 10 years in what we call serving system. Is really where by leveraging accelerated computing devices, how can you leverage it the most out of it to be able to push the inference performance? Around 2017, 18, I was working on like simple neural nets and prediction systems. And then 2020, 21, focusing on starting to on GPU, computer visions, and early days of language model. And in 2023, we really scale out and build out vLLM as an open source project for large language model and to the de facto standard in open source today. I think Jensen is right. After a model is being trained, like there's no value created after a model being trained. The value is only created when you actually run the inference process and deliver the intelligence through the inference process itself so that you can actually integrate it into your product and use it every day throughout our lives. So inference is where the core value is. You can do all the things with data center build out. You can do all the things with pre-training and post-training and trying to train a better and better model. But fundamentally, the way to leverage and actually be able to have in the future where we have intelligence on tap is through inference and is through the efficiency of inference system.
Right, right. I think many people will misunderstand inference being a solved problem, right? Well, at the end of the day, yeah, we have inference. I go on ChatGPT and I ask a question and I get a response. And I think what people underestimate is that we kind of have two levels of evolving complexity here. We have the models themselves and the architecture behind them, whether that's reasoning, whether that's mixture of experts, whether it's longer running agentic systems. So we have on one axis kind of like model complexity increasing, and then on the other axis we have kind of like hardware, becoming more heterogeneous. Whatever you want to call it, right? Whether it's kind of new players like Grok and Cerebras that are starting to make noise, whether it's AMD or TPUs, it isn't just NVIDIA anymore. And so you also kind of have a wider array of hardware to support that is growing. And so you kind of have model complexity, model architecture growing, the type of hardware and type of compute also growing, which just kind of creates a much more complicated kind of 2x2 matrix. But talk to us a little bit about why inference is getting harder, not easier, and why it really isn't a solved problem today.
It is definitely getting harder in the sense that the widening gap between full efficiency and full utilization. That is, there's always new innovations around the model core architecture itself. There's new models coming out. The reason of new model coming out is because LLMs are expanding to more and more use cases. And for different use cases, you require different kinds of capabilities and performance characteristics of the model. For example, an agent that uses voice requires one set of like human voice conversation speed of output and efficiency. But agent that runs long horizon task for coding for 8 hours straight, that require different kinds of capabilities as well as model architecture, knowledge, and everything around it. So models start to specialize and capabilities start to specialize. And then that means the system problem of running different kinds of model become a lot more difficult. Let alone that folks are saying transformer has been out there for many, many years, but actually over time, almost every few months, there's innovations in the core transformer architecture that people have built around experimented and actually improved the efficiency of transformers. Transformers are getting innovated every single day. So that's why we're always seeing model diversifies. Hardware is exactly the same thing. Because we have different workload, you have different chips that can support different behaviors. Everybody designs the physical silicon differently, and this diversity and this kind of open ecosystem allow us to mix and match different workload. And this complexity, what we typically call n by n problem in the computer science sense, is only getting harder. And vLLM is exactly in that spot to solve it.
Yeah. Maybe that's like a decent segue. There's, a lot of people who, may have heard of like inference clouds or neo clouds and don't appreciate that a lot of them are actually using vLLM under the hood as their serving engine.
Yeah.
Talk to us a bit about, what is vLLM? What does it mean to serve models? What does it mean to be an inference engine? Just kind of give us the quick primer on what is vLLM.
Yeah, vLLM is a serving engine in the sense that after the researchers have finished training a large language model, when it's at in when right before inference, it is just essentially a file sitting there trying to and it doesn't do anything. Inference is a process that you take that large terabytes of model weight, what we call, run it on data center hardware. So these are what you commonly see as NVIDIA GPU, AMD GPU, and many, many other accelerated computing device. The job is to pack as many requests as possible as acceptable performance characteristics. So think like thousands of users concurrently talking to the same model on the same GPUs, and then scale that out to thousands, 10,000, hundreds of thousands of cluster sizes to be able to handle the load globally. So serving system is really about efficiently processing concurrent inference workload on accelerated computing devices.
Mm-hmm. Which again, I'm sure it's much harder than what it sounds. And when you were building vLLM and the team was creating it, I'm sure you made some kind of architectural decisions on things to focus on, things to highlight, whether it was like memory management or paged attention. Talk to us about some of the architectural decisions you made with vLLM and kind of why that gives vLLM kind of an advantage when it comes to serving inference.
So vLLM really differentiates itself as a horizontal layer for many different model and many different hardware architecture. In the beginning, it was just a simple abstraction on a attention kernel, what we call, and then later it got built out as an end-to-end system to serve large language model. And then as of today, it is a horizontal layer, is a runtime for different model and different hardware. This is an intentional decision over time with constant refactoring and changes in innovation and reflection to figure out the right code architecture to support the different abstraction so that as someone who are making new models like Alibaba Kun, like Mistral, you are only responsible for creating the model correctly. Then, as someone who are making the chip, NVIDIA, AMD, you are responsible for making in each individual operator running fast and at the speed of light on the chip. So these combined, then everybody get access to model vendor to each other's work. Model vendor get access to best hardware support across the board. And then for hardware vendors, like you implement it once and then it works on all the past, present, and future models. So this is where the architectural decision is really settled in on that with a proper abstraction of model with hardware operator, leveraging what we call torch compile as a general infrastructure within vLLM's model runner to be able to translate the model graph into different hardware. This is really stand out as in comparison to what we call vertical serving system. So a lot of frontier lab and everything people are doing, each individual model has an individual serving system, inference system. So that is a tight coupling between the model, the hardware and cluster, and then the system itself. So what you're seeing is like model have its own vertical slices, but that's actually very cumbersome and doesn't scale in generality. And then for the entire world, right? So that's why vLLM is very intentionally set as a horizontal layer, as an abstraction layer, and built out to solve that.
Yeah. And can folks use vLLM for kind of text inference or image inference or video inference or kind of other multimodalities? Like, is it better for one or the other? Like, what part of the market do you think VLM will serve?
Yeah, so vLLM serves the market initially as just text in, text out generation inference. Then over time, we see these models become have the ability to understand images and audios and video, so we can support multimodality in and text out. And over time, the architecture also evolved to be multimodality in and multimodality out. So now vLLM is able to handle pretty much all the cases of not just text in, image in, but also text out, image out, or video out. But there's a small caveat that is we do not support stable diffusion directly, for example. We stand out, vLLM itself stand out as a what we call autoregressive generation engine. That means it is only if the model leverages the capabilities of generating new tokens after tokens, similar in the text model space, then it will be able to leverage vLLM really well. So two examples. One is if you have a text to video model, a lot of cases, the text itself got interpreted over time using a vLLM backbone. So you'll think a little bit, the model will think a little bit about what video should I create? What are the imagery? What are the prompts? What are the hidden features? Like what exactly does this user want, right? And then be able to run a diffusion process to generate that final video so that over time, when the end user are entering a single sentence, the video is exactly what you wanted, right? So this really involved vLLM in some way. So we do support that. But with this previous directly stable diffusion workload, we do not support that in vLLM.
Yeah. Well, what do you think, without kind of giving away the roadmap or the keys to the kingdom, like what gaps do you think still exist in vLLM? There's a lot of very large public companies that have talked publicly about their use of vLLM internally, whether it's kind of like the Metas or the LinkedIn's or the Roblox or the Spotify's. Like there's lots of great engineering posts that these teams have written about kind of how they're using and scaling vLLM. Like when you talk to those folks, like what do they say are kind of like gaps? Like what do you want to build into vLLM, into the kind of the community? What's kind of most important for you to add on?
So vLLM is still not that easy to use directly out of the box from day one. And this has been our constant struggle in trying to make it so much easier to use for everybody. The thing here is vLLM's interface is very simple. I will draw the analogy of a traditional transactional database, right? The interface of a transactional database is SQL. The end users and how you program against it is quite easy and straightforward. Same with inference engine. The interface is tokens in, tokens out. There's a well-documented API with any complex data type you are able to interact with the model for. But the hard problem is bridging the performance gap. Run it at full efficiency, operate it with trust in mind, and be able to run it 24/7. Running a database is very hard. That's why you need previously database admin, nowadays like a full-scale infrastructure for service database system behind it. Same with inference engine. Inference engine is fundamentally difficult. Tuning it for specific workload requires a lot of work and understanding. And specializing it for different workload requires special care. And that's why what I've been seeing from a lot of enterprise adoption and large-scale adoption today is tuning and specializing, making sure that workload not just work correctly, but also work at maximum efficiency, maximum speed, given especially how expensive the hardware can be. That is a real challenge nowadays. So that's why we're really much working on efficiency, working on the ability to tune and adapt, and ability to make sure that new models can be added and you can leverage this new model for new use cases directly out of the box very easily. Performance, usability, and all that suite are there to go for this complex system.
Yeah, awesome. Maybe decent segue into now the company you're building, Inferact. Like what is Inferact's relationship going to be with vLLM, with the open source community? What do you want to, how do you want to think about the kind of company you want to build? Maybe talk to us for a second about Inferact.
Yeah, so Inferact is funded by the creators and maintainers of vLLM. And we are continuing to, just like we have been before, stewards of this project. We really believe that the power of vLLM really comes from openness and the entire community. So we have more than 2,000 contributors in the VLM project, and we just cannot have what we have today without such a very much engaging, powerful, and community that like-minded people working together. So what does this mean is Infract exists to accelerate the development and adoption of VLM. We'll continue to put a lot of resource, hire great talented people to work on VLM, building feature, aligning roadmap, and coordinating the entire ecosystem, continue to solve the end by end problem for a model to hardware matching and pushing it to the enterprise adoption.
Yeah.
Infract will also build the ecosystem around it to make sure that we deliver the final mile of an inference at scale. And what we believe is vLLM as a standalone open source project is great to use and great to operate, but it's only also one piece of the puzzle. To solve the entire story about inference, you need to go from hardware selection, model enhancement, all the way to the final 24/7 on-call to be able to make sure it scale and run reliably. A lot of the pieces can be built and need to be built around the core vLLM engine itself, as well as end-to-end direct vertical integration to make sure it works smoothly. So in short, Infract exists to accelerate vLLM and then have the mission of bringing efficient intelligence and accelerating adoption of AI across the globe.
Yeah. And, we've talked about this in the past, but you kind of have like a couple constituents here. You have like the hardware providers, the compute providers, and then like the model providers. Like, what would you like to say to, both of them, right? Whether it's NVIDIA or the kind of Cerebras, Grok, AMD, Google TPU, others. Like, what would you want to say to the model providers, the compute providers, and and also like, what would you want to say to the model providers about like, hey, how should you be interacting with Inferact?
Yeah, so it shouldn't really change, right?
Yeah,
Like what we're continuing to build is as a team, as a community, we are absolutely open-minded to be able to collaborate with everybody. And open-minded doesn't mean we'll say yes to everything. We want to continue to govern and push the technical project forward, focusing on the end user in mind. But what we want to and continue to commit to is to continue open up the ecosystem, work with everybody in here to be able to help each other build on top of others' work, innovate, diversify, and be able to accelerate the progress at what we believe to be the maximum efficient mode. So we continue to make sure that model are accelerated and added on day one, continue to make sure when new silicon arrives, we are there to tune the software performance together, designing new paradigm, refactor everything if needed to be able to support it best.
awesome, awesome. Maybe last question here for me. The world of AI is so dynamic. It seems to change every day, every week, certainly every month. I like to kind of think about what the future could look like. And specifically, what does the future look like if a company like Infract is successful? Like, how do you think about that world? Like, what will you unlock that, wouldn't have been unlocked like without Infract, without vLLM? But like, how do you think the world of AI changes if this company is successful?
It's again drawing the analogy of databases, right? Thinking about how hard data was before, you require a DBA, you require different kinds of tuning, and you previously Oracle database a single rack on server, a single rack of some servers. But nowadays, serverless database, one-click deploy, direct lakehouse integration, right? This whole process, what does it enable? Enable us to have data everywhere and to be able to really like massively accelerate the amount of data every single person, every single organization, enterprise generates, process, and benefit from it. And we're not even at the end game of big data. Like data is still there and still untapped, right? And then AI is the next evolution of it. Intelligence pretty much on the same trajectory. What I see here is we need to build a system to enable and fundamentally abstract accelerated computing devices, just like database abstracted away storage, that we need to build a system on top, layer on top, infrastructure around it to make sure that we can have free flowing intelligence around our life in our organization and support everything we do. And once if our job is there and successful to make inference more and more efficient, accelerating the adoption of AI, then I believe like just like how data around us are getting exponentially increased, compute cycles that are associated with everybody's daily life exponentially increase over time. Intelligence that will help us and help the human progress will continue to grow there. And that's kind of our job to make sure that efficiency is delivered. Efficiency promises is delivered. Keep in mind that a model is only useful when it's running inference. So we're really much at the core step there and want to make sure it's not just realizing a single digit percentage of efficiency. Rather, we want intelligence to run at the speed of light, run at the full capability of the silicon, and then really to help people to leverage that.
Intelligence at the speed of light. I think you have, if you didn't have one already, I think you might have like a company tagline or motto. Well, look, Simon, this has been great. We couldn't be more excited to be partnered together on your journey. We think you've assembled a pretty amazing team that is uniquely positioned to solve one of the most challenging problems in AI infrastructure, which is efficiently delivering and serving inference at scale. If there's roles you're looking to hire, maybe just kind of give a quick shout for any open roles, and I'm sure people would love to get in touch, but we couldn't be more excited to be working together.
Yeah, thank you for having me. We're definitely always looking for great, talented engineers and researchers to join our team to focus on building the future of inference together.
Awesome. Thanks, Simon.
Cool. Thank you so much.